Okay, so we are now on lesson 4 of chapter 7. This time we will be dealing with proportional lines and parallel lines and proportional parts. So even though in any polygon we can always go back to the original definition of similar polygons wherein angles are congruent and corresponding sides are proportional. In any case, that's the basic of similar polygons. But we just have separate lesson for similar triangles last time because of the special properties that might be easier compared to just using the original definition of similar polygons. And also now we have here a special property that involves parallel lines. So there is something that is special with respect to proportional parts if there are parallel lines within a triangle. So we have the triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, that means if there is a line parallel to one side where it intersects on two different points on the other side of the triangle, of course it's referring to this because the side of the triangle, which it's this one, it's the one that it's referring to parallel to one side is this, so you're left with these other two sides. So it goes from one side to the other side, vice versa. Then if these two lines are parallel, it says it separates these sides into segments of proportional lengths. In simple terms, simple words, so that this line makes these segments here, I'm talking about CB and BA, these two segments are proportional to these other two segments, CD and DE. So when we say they are proportional, that means the ratio that you make here is equal to the ratio that you make on the other side of the triangle. So it's just like you extend this side and you extend this side. Okay, so if you extend this side, you also extend this side, this becomes your fraction bar. This line becomes your fraction bar. The red lines that I just made becomes your fraction bar. So you get fraction from this side equals to another fraction on the other side of your triangle. And that's why you see there, you see that we have BA over CB. Where are these segments came from? They came from one side. This is your BA over CB. And CB over BA. Doesn't matter as long as you have to be consistent. So if you do BA over CB, then the fraction on the other side would be DE. That means this DE will be your numerator over CD. CD as your denominator. But then again, for consistency's sake, you can also do the reverse, but be consistent. And so the other way of writing these two is to write it as CB over BA. Okay, CB over BA equals to CD over DE. So that is how you make fraction, and from there you go back to the rules of the process of solving a fraction equals a fraction, that the one that we just been using in this chapter 7, and that is getting the cross product and then solving for what is being asked for. So that's the basic of triangle proportionality theorem. So that's how you make equation, proportionality statement, if there are parallel lines within your triangle. So next we go to the next theorem. Let me just erase this one first. Okay, let's go to the next page. We have the converse. the converse of the triangle proportionality theorem. You see the triangle? The triangle does not have indicators that these two lines are parallel. Now, the converse is telling us how to identify parallel lines. So the converse of the first of the triangle proportionality theorem is this: if you see that the ratio of these two segments here is equal to the ratio of the other two segments on the other side. Let's say you make fraction here. The answer for your fraction here is 2 over 3. And you make fraction on the other side. The simplified answer of the fraction on the other side is 2 over 3. That means these two sides having this end of the line, because of this B and D that makes it two different segments on both sides. That means these two sides, the segments on the two sides, are proportional. So they can only be proportional if these two are parallel. So it follows that if these two ratios here from the two sides of your triangle are proportional, then the two lines there are parallel. So you see, if BA over CB is equal to DE over DC, then these two lines are parallel. So you can do cross product and check if the product on the left is equal to the product on the right, or you simplify this separately, simplify this separately, and if you see that they are the same, then the two lines here in your triangle, of course referring to the one that is inside your triangle, is parallel to the side to which it's parallel to, or to which it's facing to. It's not crossing there. So this is we are checking if these two sides are parallel. Okay, and then the third theorem is the triangle mid-segment theorem. So a mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So there are two things here. When we say that a line is mid-segment, then that line, the starting and the end point of the line are the midpoints of the sides of your triangle. So B here is not just an ordinary point, but it's the midpoint of C and A. That's why you see these small lines telling us that these two segments that was made up of point B at the center of them are equal. And on the other side, point D is the midpoint of C and E, and that means CD and DE are congruent. So not necessarily that all of these are congruent, but we see that these two segments are congruent, these two segments are congruent. So that means BD is a mid-segment of triangle ACE. So what happens if it's a mid-segment? First, it's that the length of this is 1/2 of the length of the line, the side of triangle to which it's parallel to. So if this is 10, this is 5. If this is 20, this is 10. If this is 50, this is 25. The reverse. If this is 25, this is 50. If this is 20, this is 40. If this is 10, this is 20. And this is 5, this is 10. Like that. Okay, aside from that, if you see that these two segments are equal and it's proportional to this, and these two segments are equal and these two lines are parallel, what can we get from there is that the other sides here are also, the other segments on the other side are also congruent. Okay, like for example, if you're not given that these two segments are equal, but these two segments on the other side are equal, provided that these two lines here are parallel. So clearly on this side we can say CB equals BA. There are times we don't need to do complicated equation. We can just say CB equals BA. because of this, because it's a midpoint. So if this is a midpoint and it's parallel to this side, that means on the other side of the triangle, that's also a midpoint, and that means CD is equals to DE. Okay, so we'll go back to those one by one later by solving a particular example. So let's go here. Okay, so for the first theorem, the triangle proportionality theorem. So this one, these are the two lines that are parallel. So from the triangle proportionality theorem, just like we extend this side, I mean the one inside your triangle, just extend that one, and you see that you have fraction of this over this segment equals fraction of this over this segment. So that gives us EH over HG equals FL over LG. You see, EH over HG equals FL over LG. So this is one. These are the segments here. EH over this equals this over this. So you see, we're not crossing from one side to the other side. We simply get a fraction from one side equals to a fraction on the other side. Then replace with what's given. EH is 9. HG is 21. FL is 6. LG is unknown. So we replace and then cross product. So 9LG is equals to 21 times 6. 9LG is equals to 126. Divide both sides with 9. LG is equal to 14. Okay? Now, let us discuss the second to check your progress. What if? So, I have here. So, in triangle EFG, if EH is 6, so again from here, our original equation or proportionality statement is EH over HG equals FL over LG. So take note that these four are segments here. We don't use here a length from E to G or F to G. So if you're given with a length from E to G and F to G, you don't use that one in your solution. What you use are the smaller segments. So you find a way using that whole thing. If you're given with the whole thing, find a way to use that